Laws of chemical combination. The laws of chemical combination are the rules that govern how atoms and molecules interact to form compound. So generally in a chemical reactions, there are rules that govern how atoms or molecules react to produce a molecules. In a chemical reaction, we have reactant, where the reactant combats to produce product. So in the course of these reactions, there are rules that guide how the reaction take place. So ladies and gentlemen, let's look at how some of these reaction take place. You see here we have A and B. So A and B here are the reactant, while the product is AB. So this is a typical examples of combination reaction. So you see here there are two atoms that interact to produce A and B as a product. Sorry, AB as a product. So look at this. We have sodium plus chlorine to produce sodium chloride. It's also another examples of where two atoms form one single molecules. Then in the case of water molecules, a water molecules is a molecule, so it's not an atom. So it decomposes to produce carbon, to produce oxygen plus water. And of course, there is an arrow that indicates the forward and the backward reaction. So this is a typical examples of how reaction takes place. It can be between atoms and atoms or a molecules. So let's look at another example, that is the production of ethanol. So you see here is also another molecules where we have ethylene react with water to produce ethanol. So ethanol is a product, while the ethylene and water, they are all molecules. So you see in this case, it's a molecules that interact to produce another molecules. So there are rules that govern how this reaction takes place and how the reacting particles behave. And we have 5 major rules that govern how the reaction takes place in any chemical system. So ladies and gentlemen, let's now look at the 5 rules that are used to govern the reaction. So we have 1, laws of conservation of mass, laws of definite proportion, laws of multiple proportions, Lussac's law of combining volume, and then Avogadro's law. So these are the 5 rules or laws that are used in governing any chemical reaction that takes place in the body. So we are now going to look at 2 of these rules in this video, starting with the laws of conservation of mass. So the mass can neither be created nor destroyed in a chemical reaction. So generally in a chemical reaction, especially in a closed system or isolated system, the mass can neither be created nor destroyed, meaning that the mass of the reactant is always equal to the mass of the product. But in a situation where you have a gaseous molecules taking place and is in an open system, of course the mass of some of the reacting particles or the products may be lost. So let's actually now look at how some of these reaction take place and then the mass that maintain between both the reactant and the product, meaning that the total mass of the reactant and the mass of the product are always the same. So let's look at examples. Here we have a combustion reaction where methane burns in the presence of oxygen to produce carbon dioxide and water. So you can see clearly here the mass of the reactant, which is methane and oxygen, is 80 grams, while the mass of the product, carbon dioxide and water, also remain 80 grams. So meaning that the mass of the reactant and the product are maintained. They are all the same. So in a chemical reaction, the mass of the reactant is always equal to the mass of the product. So ladies and gentlemen, let's look at also the next law, which is the laws of definite proportions. It's also a law that also guided how chemical reaction take place. Okay, so then the law of constant composition, or the law of definite proportion, is stated by force in a chemical substance. The elements are always present in definite proportions by mass, meaning that in a chemical reaction, the elements that are present in a particular substance or in any chemical substance, the element always remain defined, they remain the same in also the same proportion, irrespective of where the substance came from, irrespective of the method of the preparation, irrespective of the sources of the substance. Or you can say that all chemical compounds are found to have finite composition irrespective of their method of preparation or sources. Like for example, if you have water molecules is made up of hydrogen and oxygen in a ratio of 2:1 or 1:8 or 1:8. So that proportion of elements will remain the same irrespective of the sources of water, whether it is rainwater, whether it is well water, whether it is tap water. Irrespective of the source of the water, the element in water, provided that the substance is few, so the hydrogen and the oxygen will only be present in water molecules, and the ratio will also remain the same. So let's look at examples here. We have hydrogen plus oxygen to generate water molecules. So we have 4 grams of water, 4 grams of hydrogen and 32 grams of oxygen. So by mass, if you take the ratio is 1:4. So here the ratio is 1:8. So it's irrespective of the sources of the water molecule, the ratio will remain the same. The elements that are present in water molecules will also remain the same. So ladies and gentlemen, join and subscribe for more videos. I hope you will find this video very interesting and attractive. Please join and subscribe, and in this video I'm going to also attach the link to other laws. Thank you.